So this is Snag, the stereotyped nature-inspired aerial grasper. And we use the word stereotyped because just like birds, it does the same landing behaviors no matter what surface it's landing on. The legs and feet were inspired by peregrine falcons. Just like birds, it has 2 legs that can move independently. Also, just like birds, this robot has a rigid leg structure and foot structure that's acting like the bones. It has motors, which act like the muscles, and it transmits forces through tendons. So once the robot hits the perch, the accelerometer in the foot lets the robot know that it's made impact and that it should initiate its balancing process. As the robot absorbs its kinetic energy, it then grasps the surface. The toes and claws wrap around to engage with surface features. And then the robot can use its balancing algorithm to balance itself over the top of the perch and remain stable. One part of what makes it so hard to mimic what birds do in robots is that in the natural environment, there's so much variability and complexity and uncertainty. In a lab, we can control everything. When COVID hit, I moved to rural Oregon. I was lucky to be in a forest where there were plenty of places to test this robot. In a forest, you can encounter branches that are wet or dry. They might be smooth or rough. Some branches have branches branching off of them, and so a robot that can be successful in those types of environments must be able to handle a huge variability. Most of the structure on this robot is 3D printed. What's especially cool about that is that a lot of these mechanisms are printed in place. That means that a whole foot segment and a whole leg segment can be printed out in one print, and right off the printer they have all the joints built in. They have all these components moving together. We can rapidly iterate to make these different mechanisms work really well together. Most aerial robots, especially robots that rely on rotors to keep themselves hovering in the air, can only fly for about half an hour. And so the ability of this robot to perch and save power enables it to study the environment over much longer time periods.